All right, let's get started. So today we'll continue with evaluating algorithms. So recently we just made video about building blocks of algorithms, and so it's already happened like 3 months or 2 months. I'm not sure. Let's get started. Don't forget the topics. So we will continue with the evaluating algorithms, and the subtopic will be verifying an algorithm. So let's verify the algorithm, what it is. An important aspect of any algorithm is that it's correct. It always produces the expected output for the range of inputs and it eventually terminates. As it turns out, it's difficult to prove that an algorithm is correct. Programmers often use empirical analysis to find result and is an algorithm, but only formal reasoning can prove total correctness. Yeah. So in this case, I will just show you something about this empirical analysis. So how we doing that? Let's say we have minimum number, maximum number, or average number. How we can find it? We can just create such a loops and the conditionals to find it with the computer stuff. So yeah, first we will look for the pseudocodes. Pseudocodes like a human system, okay? We biologically created that, but the computer working in different way. But the computer is also representing ourselves. Anyway, I don't want to make such a philosophic discussion, but let's continue with the scientific way or the technique. Okay. So empirical analysis, our first topic. Let me get my pencil here. I'm speaking like a parrot, but yeah, this is the way to explain things. Anyway, yeah. An empirical analysis is one based on actual experimentation and observation of the results. So in the world of algorithms, that means the algorithm must actually be translated into a programming language and executed on a computer. Yeah, if we don't do that, then what will happen? We can just write so each other like a papyrus. It's not way to explain things because if we are working about digital things, then we need to use programs and programming languages, isn't it? Okay. It is another language to speak with the computer. Yeah. Let's conduct an empirical analysis of an algorithm that finds the maximum value in the list of numbers. In this case, we will just look for the maximum number, how we can find it with the algorithmically, okay? Normally, just think you have a list, and in your list, you have such a numbers like 5, 7, 2, and then 1,000 and 500, but they are mixed in the mixed ordering, okay? We just want to find the big one. How we can do it? We can just check each of the numbers step by step, and we can find the maximum one, isn't it? Okay. Let's do it. Here is the pseudocode that expresses that algorithm. And as you see, we have maximum number. It's represented with the -1. So that you see, we have a variable in here. We can just say in the JavaScript like let. We can use let because if we use const, then we cannot get the output in a good way. Uh, as I explained to you that before in another course, another my course. So anyway, then we have for loop, and in for loop we will just say for numbers of no for num of numbers we can do such a jobs like this, and we can check with the conditionals each of the stuff. We can just get output, and in this case we can use for of and for in loop or for var I equals 0 such a things. Anyway, I don't want to speak a lot, just do it. Let's come here. First, let's say let max number is -1, not 0, 1, -1. Okay. Then we have another things, numbers. So we can just open const in this case. Let's do it like that. We can just say numbers like, let's put 7, 11, 23, and 8. Thousand, or if you do it such a big numbers, then computer will track each of the cases in the list what kind of numbers we have, like 7, 11, 20. The computer will just say during checking that, oh, 7 is not greater than 11, then it's not that, and 11 is not greater than 20, and it's not that, and it will look 3 or 3 is not greater than 7, 11, or 20. So yeah, computer just will work in this way. Anyway, so let's continue. I will write code very fast. I don't want to speak like a parrot again. So let's do it for num. We can just represent it like num, but let's use const again there, like yes. Const num, if num, like for num of numbers. Yeah, in this case, we can just take output. In each case, it's like a numbers. If we use in, then it will give us index. We don't want it. Numbers. Yeah. Then let's continue with if conditionals. We can just say if number is greater than, if greater than maximum number. Yeah. Then what we need to do, we can just say what we can say. I must remember. No, I must think. Okay. Yeah, we can just say max number is number. Yeah, and then we can just come down and we can just say console.log and we can just put the maximum number. Yeah, I hope everything works great. If not, then I will cry for a minute. Yes. As you see, the number is 1000. So I found the result. As you see, I prove you. So it is empirical analysis, okay? We just said if number is greater than maximum number, because number is the part of the numbers, and in the numbers we just making such a loops to make iteration to check each of the numbers with the number. Okay, it's like an indexing, and we just saying if number is greater than maximum number. In this case, our maximum number is -1, and we know that 7 is greater than -1, 11 is greater than 7, and yeah, shut up chair. So it's all. Let's continue. I mean, we already found the result. We can do such a job same way with the what with the another one for I equals and such a things like same way. So how we can do it? Let's do it with another way. What we can say? We can just say again, let's max number equals -1, and we can just put their numbers again. Let's do it like the numbers, and but we can put const there. Yeah, numbers equals, then open the list, and we can just say 6, 8, 20, 25, and 300. Okay, doesn't matter what happened here. Yeah, so now we can just say for I equals 0, I if I no for I less than, like if I less than numbers, yeah, dot length. In this case, we will use this term, and we will say I plus plus. Yeah, and then we will comment it and we will say if what if numbers, and we will put I index in it because it will iterate each time in the numbers index. Yeah, if numbers I index is greater than what, greater than, but I just forgot something in here. Let me check it again. uh yeah, I think it's true. So max number, then we will do such a different jobs. Like what? You can just say max number is max number is what? Numbers dot I maybe. So maybe we can find the result in that way. Maybe I can make another arrangement, but let's try it. I mean, let's see what's going on in here. We can just say max number. Yeah. Aha, we found another result as you see. So I'm always true. I really hating from that situation, but I am correct again. So I'm much logical anyway. So that's another result. As you see, we found 300. Okay, so it's not 20, it's not 25, it's not 6, it's not other things. It's 300. We just tried with the for loop with the indexing model like I, and we also tried it with the Another way, like a for num of numbers, for I equals 0, and other ways too. So, okay, they are all same. I mean, we're just looking for the result in here. I hope you understand, guys. I hope. If you don't understand, just don't ask me another question. Just look in internet how to find it. Then we need to feed input into the algorithm and observe how it performs, blah, blah, blah. So I already did this and you understand how it works, right? Put this one here and yeah, we just did all of them. I explained it to you. What is this one? Max number is, yeah, in this way we have negative number. What if we have negative number and what will be the result? What do you think? So let's say we have minus 30, minus 4, minus 24, and minus 7. In this case, as you know, minus 1 is greater than all these numbers because it is minus, because it is entire numbers. It is not natural numbers, right? So what can we say? Let's go back there and just change numbers like minus 6. Okay, yeah. Minus 8, minus 20, minus 25, minus 20, no, minus 300. Yeah, as you see, the result is minus 1, guys. So as we found again, same way. So it's true. Yeah. Anyway, let me laugh a little bit and drink coffee. Yeah, guys, it was my trick. Now, what is the trick? We have here numbers in the list. As you see, we have minus 6, minus 8, minus 20, minus 25, and then minus 300. But as you see, maximum number is minus 1, right? But in the numbers, we don't have such a numbers like this. So how did you find this result like this? So we have something wrong in here. And so did you detect us? So if not, let me detect. Yes, guys. Now let me show you where we did something wrong. As you see here, that maximum number was the minus 1. And when we run this, it gives us minus 1. But as you see, the answer is not that. Answer is minus 6, guys. How we can find this result? We can just say we must get the index of the numbers from 0. I mean, first index. If we didn't do that, it will always give us minus 1 because for the positive number we can just do minus 1, it doesn't matter. But when you make for the negative numbers, then we must indicate that we are in the numbers. We must represent it with the indexes. So yeah, we can just say take this net maximum number and we can come here, we can just say numbers and we can just type the first index of the numbers is it is minus 6, isn't it? Yeah. So maybe you will say you choose directly minus 6. No, you can just put there minus 300, or let's put there minus 500 to just prove you that what is going on in here, isn't it? Okay, when we run this now, as you see, the answer is minus 8. So we don't have minus 6 anymore. So the minus 8 is the greater number, as you see in here, right in our numbers list. So just don't confuse when you have minus, like negative numbers, you can't do same system as we did before for the positive number. So for positive number, you can put there minus 1, minus 5, minus 7, it doesn't matter, but you have in your list, you have always positive number, so it works. But when you have in your list such a like negative numbers, it doesn't work in that way. Okay, so you must put there some indication with the index of the list. So we must indicate like a list first index, then just control each of the items step by step in the list. But if you have positive number, you don't need to do anything like this. Okay. Anyway, I hope you understand. Let's continue. Yeah, we fixed two. We don't have any problem with this, guys. No, that works. Yeah, we know that works. We can do the testing more easily by wrapping our algorithm in the procedure and using a testing library to assert that output from the procedures matches what we expect on Khan Academy. By the way, you can check this Khan Academy. I'm all using their information to explain you things, but all the contents from them. Okay, I'm just explainer in here like a teacher. Okay. So we can use program that assert, equal, then we can put actual, expected, and in this case we can find the real things like what we are looking for. Okay, so you can just check it with that, but as I said you before, we already wrote this function, sorry, not function. We already made this algorithm and we found the result. You can just check it on Khan Academy website. You can find there or you can check the numbers step by step. No errors there. Yeah, there will be no errors. By the way, it's for you the, uh, the like a task. Okay, just go there and check it. So empirical analysis can only be used to prove that an implemented algorithm is not correct by discovering inputs where the output is unexpected. However, it cannot prove that an algorithm is correct. Yeah, it's sad, but yeah, it is. Formal reasoning. This is another important one. The only way to prove the correctness of an algorithm or all possible inputs is by reasoning formally or mathematically about it. So one form is reasoning proof by induction, a technique that's also used by mathematicians to prove properties of numerical sequences. Yeah, you can just check on Khan Academy these things too to understand all of this stuff, and you can make such an exam. A metaphor can help with understanding induction. Imagine we have a line of million dominoes. Oh, by the way, let me go a little right. Yeah, dominoes are perfectly spaced out. How do we know the every domino will fall when we tip the first one over? We don't actually have to check individual domino. We only have to prove that one for when the first domino will fall and the two like a tipping over any given domino will tip to the next domino over with just using two. Yeah, it's very long, you can read it. Now let's apply induction to an algorithm. Here's the pseudocode for an algorithm that computes the factorial of a positive integer. So let's just do it. Yeah, so let's get started with the checking the calculation factorial. So we can do it. We can just understand factorial of a positive integer. So how we can do it with the programming? So we can just come here. Let me delete all this code or remove. We can just use like while loop in this case, and we can just put their function. We can just say function calc calc factorial, and we can just come in it and we can put n number. N number can be anything else, so we will put their number in it. It's not n number like infinity. And we can just say while, yeah, n is less than what? In this case, it is important. N is less than what? I or n? What do you think? Let's come back here and see. We have I, right? So we now have n. We come to the same thing. So we cannot make it like this. We can just come here. We can say I because our I will be 0 in this case. How we do that? I will show you. So while I is less than n number, number can be anything else, then do such operations. Like what? So we can just say n is equals I time, sorry, I just mixed up. Sorry, 1 minute. Yeah, factorial. We will use factorial in this case. By the way, I did something wrong. Yeah. Anyway, take it back from here. So we have factorial, indicated factorial. We can do another way too, but let's do it like this. Factorial, and we can just say for factorial, it's in this case we represent it in Khan Academy program is like a one. We can just say one, and after that we can just continue. So we can just say if I is repeating process, but before that also indicate the I. So we can just say let I equals to 0, or maybe we can say 1 for both of 0 for both of them, maybe, or 1. I don't know. Just do it 1. So okay, or just say 0. Okay, like it's for the repetition. So then we can just say for the factorial time I, because I will be repeating like in while, right? So we can just say, come here, and we can just say factorial equals, or just say plus equals, maybe you can use this term, it is better, I. So it means factorial time, factorial equals factorial time I. So in this case, factorial will be any like a 1, and we will just multiply it with the index, repeating index, like 1 times 2, 1 times 3. Like it will just continue in that way to return itself, okay? So then we will found there, by the way, let me also make this like a plus 1, because in each repeating there will be such a process like 1 time, and we can just return factorial in here, isn't it? Let's check it. Yeah, return factorial, and we will just console that. We will just put there this function for the result. Console dot log. I just mixed up for there. Sorry. So let's continue. And we can put such a numbers. What can we put there? Calc factorial. And we can put for the factorial what number? Maybe we can say 5. Yeah. What will be the result? Let's check it. 11. Is it 11? What do you think? Is it true or false? So let's check it in here. So if you put 4, what will be 4? I will show you one important thing in here. If you say 4, what will happen? 7. It's wrong. Why it's wrong? Let's check it in here. Normally it must be 24, right? How it gives us that result? What is wrong in this case? Because we put here plus, first make it by multiplication. Let's try it again. It's 0. What's going on in here? So if you check factorial in here, it's 1, right? And our I is also that one. So what if we say, if you see here, we have 1 for both of them, isn't it? So let's say 1 for I2, and what will happen now? 6. Is it true? Not. Again, right? So what is wrong in this code? Just think. We have repeat until, this is while loop. We're saying if I is less than n number, it will always increase, right? So we have factorial 1 and the I is 1, and they are in repeating process, and return factorial is out of the that way we used already like this, but the result is still same. So why it is like this? So what do you think if we make for like both of them like a 0 like this, and we put their number, then we just try it. It's 0. So as you see, the numbers just in wrong process. So to prove it, we can make such a different work. Like what? So everything true in here, and everything true with the factorial timing, like multiplying. But as you see here, we have I is less than n. So in pseudocode, it looks like this. So what is can be wrong in this case? So what we are doing wrong in here that we cannot get answered. Yeah, I got my coffee back. Anyway, where's my coffee? Let's continue now. I will show you 3 points to fix this problem. If we say for the factorial is 0, it doesn't work. I 0, it can work, but we looking for the meaning to find best result. And we have one conditional operator here, like a less than, like I is less than n in the function. So just think, you have number 4. It will just repeat like 1 time, 2 time, 3 time, and it will say the 3 is not equals 4, it is less than 4, and it will stop. But we don't want it. We want until it reach out to 4, right? Then we can just say it will be factorial calculating, because factorial works like this. Yeah, 4 times 4, 4 times 3, 4 times 2, 4 times 1. Yeah, it's just multiplying with itself. So we can just say factorial is 1 for the variable, and let is 1. So they can just start from 1, excuse me, okay? So then we can just put while I less than or equals n. N number can be anything else, but it will be equals to it. So we can just say 10. It will give us this number. What if we say 3? What will happen? Let's say 3. It's 6. 3 times 3, 3 times 2, no, 3 times 2, 3 times 1. So how it in calculation? Let's look in here. 4 times 3, 3 times 2, 2 times 1. By the way, I think I explained wrong about this too, factorial. So you can just think like this: 3 times 2 times 1. By the way, it was like that. I just mixed up again. So if you multiply that, 3 times 2 is 5, 5 times 1. Sorry, 3 times 2 is 6, 6 times 1 is 6. So as you see, the result is 6 left side. So we can just calculate in that way. So we need two variables like factorial and I for the while loop, and the factorial for the just make multiplication. And we're using factorial time equals I, like factorial equals factorial time I. Factorial, if factorial is 1 and the I become 2, it will just multiply it with itself. And we have here n number. As you see, we put here 3, and if you check the result in here, we're returning factorial, right? Factorial time I, we are looking for this, right? Factorial time I means factorial will become 1 in this case, and I will be 1, 2, and 3, and 4. So each time it will just multiply it with itself, and it will increase factorial and sorry, if I indexes, and it will just give us the result each time. Yes, guys. Now, as you see, factorial time equals I means the factorial each time will be multiplication with I. Let's say I is 1 and factorial is 1. 1 time is 1, right? And we have number there. So we put there 3. So we saying if I is less than number, in this case, it will make it repeating 3 times. So just think about it. 1 time 1, like I, will be 1. It will store data there, and it will increase I, and it will just go back to the first point, and factorial in this case will become another number, right? In the repeating process, and I will become 2. And if we say I is less than number, again 3, in this case I is 2 and the number is 3, it will just make it again, and factorial was the 2, let's say in this case, and the 2 times the number again, 3, like 3 times 2, in this case it will be 6, and it will multiply itself again. I think it is so mixed explanation, just try to understand it, okay? So in the visualization it's a little bit different, but in the while loop you can understand everything clearly, okay? Factorial is 1, in the factorial that we be saying each time, like factorial time I, it's just storing data, okay? It's 1 time 1 is 1, just think like this. But we're returning factorial in this case, and we just saying for the calculation factorial function, we're just using number 3, okay? If our number is 3, we will apply same things each time for here. As you see, our number is 3, it will make 3 times repeating with the I. and the factorial will store each of the data in each process. So factorial will become 3 and will become 2 and will become 1. So it will just multiply it itself. Okay. Yes, guys. So let's continue with another topic. I hope you understand. All right. It's just easy. Okay. Just focus on the factorial in this case. No need more explanation because factorial will be updated each time with the I. So as you see here, factorial, last time I'm explaining you final, okay? Factorial is 1, I is 1. So if we say while I is less than n number can be in this case 4, okay? Let's say 4. So factorial will be 1, I is 1. So if we say I is less than n, then we can say factorial time I will be factorial in this case. Now factorial is 1, I is 1. 1 times 1 is 1. Now we're increasing I 1. So we go again into the loop. And loop saying I is now 2. Factorial is still 1, right? If I is, so while I is less than n, so this conditional, if I is less than number was the 4 and 2 is less than 4. In this case our factorial is 1. I mean our I number is 2, right? So 1 times 2 is 2, and now our factorial will become 2. So and I will be increasing again. So if you go back here, factorial will stay 2 and our I will be 3. 2 times 3 is 6. It is our factorial. And if we repeat one time, if we increase one more time, it will be uh, 3. And if we check it again, 3 will be less than this number. And it will just multiply with the 6, sorry, with the 2. And then it will continue with the 1. And it will give us the 24. Okay. I hope you understand. Just do the same operation each time until the condition becomes false. Yeah, this is the same explanation that I'm explaining here. You can just rate it. Rate will verify that the algorithm computes the correct result for a single integer. Now let's prove that for all positive integers, the algorithm computes the factorial of the integer. So yeah, you can read here, I mean, n plus 1 you're using this system. Base case, this is where we verify the algorithm holds the very first number in the range of like possible inputs. Yeah, it was in the first case again. This variables factorial both I starts off at 1 since I is 1 is not greater than n number. So the algorithm enters the loop again, iteration starting there for this, and 1 times 1 it increasing each time to I. So yeah, this is more explanation about it. You can just apply each of this stuff to understand what is going on with the factorial problems, okay? It's also okay, I think. Proof by induction is technique that works well for algorithms that loop over integers and can prove that algorithm always produce correct output. So we can just prove it in that way, okay? It's correct. I mean, we knows like how it works. Yeah. So we already completed this step. I hope it was clear or comprehensive during explanation. If not, just ask your questions there. By the way, today I was a little tired and I hadn't focused on topic. So, but yeah, I must share this video because it was happening for a long time. I didn't share, and I have another courses and things. Yeah, I just try to focus on it anyway. So I hope you understand. Just check all of the codes to understand the main point in here. Okay. So what is that? What's wrong in here? What did come here? So yeah, that was all, and thank you so much for the watching. I hope you understand. We will continue with the verifying. Sorry, by the way, we have practice questions. Yeah, so I will put them for you to just work on it. Okay, I will put question here. That means that you can just solve them and you can share with me in the comments. Yeah, we have such a questions about this verifying an algorithm problems. So you can prove your algorithm like algorithmic way in here. By the way, to understand the topic, this is our second question. Yeah, it's not seems like a question mark, but yeah. So we have again same thing in here. Just prove that which algorithm is true, like algorithm one or two or whatever else. So as you see here, we have 3 power of 1, 3 power of 2, 3 power of 3. So you can just check each of them to find a result with the algorithmic way. As you see, we have such a two ways, algorithm 1 and algorithm 2. You can just answer this question in here. And the third question is the same logical way that we checking algorithm, which one is better or are they true or not. So you can just work on it, okay? All of them is question for you. You can also check in Khan Academy to find all of them. So this is another one. All of them same things, just try to understand how you can understand this algorithms or how you can prove or how you can verify them. Okay? It was the last question, by the way. It's that one. I mean, yeah. So we will continue. By the way, what happened? Yeah, here. We will continue topic with the measuring and algorithms efficiency. It is part two. Let me add here. The first one was the part one for this topic. It is part two, our second main topic. Part, or we can just say part 1.2, something else like this. Or maybe you can use different terms like part 2.1. Um, yeah, maybe we can do it like that, or we can just use another way to just explain. Anyway, I will not put anything in here, so you can just stay like this. I mean, just tag this one from there. I'm so silly today. So yes. We will continue with the measuring and algorithms efficiency. This is subtopics of the evaluating algorithms. It is the second part of the course. Let's continue with this one. I hope I will do it in a one shot, but if it doesn't work, anyway, let's just say part 2.1, okay? It is much understandable for you because maybe I can make 2.2, 2.3 and such things, okay? Just think in that way. Part 2.1. This, yeah, but like this. See you in another course. We already completed first part. I hope you understand everything correctly. Yeah, that was the cost of day. I mean, yeah, it's just finished. Thank you so much. Bye. Bye, guys.